So for in your assignment question 2, it's a merit question on dimensional analysis deriving equations. So the full set of notes will be up with all these examples filled in, but this recording just talks you through it. So before completing this question, you need one more primary dimension that we haven't talked about. And it's charge, and it's represented by Q. Okay, so current is charge per time. It's a flow of charge. So the primary dimension of current is Q over T, or QT to the -1. Okay, so we didn't talk about this in the first for question 1 because we didn't need it at that point. So some other electrical dimensions you should know. So voltage is L squared over QT squared. Current is Q over T, and resistance is ML squared over Q squared T. So just be careful, because voltage and current, or sorry, voltage and resistance look very similar, but it's the denominator that's different. So don't get mixed up on that. So the equations that you're deriving in your assignment, you should already know them. So power, or you can look them up. So power with linear velocity, power with force, I think, and power with current, or power with voltage, can't remember. So you can look them up so that you know what you're supposed to be getting. But the key to this question is, the trick to these questions is to pretend that you don't know them. Okay, so don't start your question off with saying power equals whatever. It's okay if you know that in the back of your head, but you should start off with an unknown quantity and then arrive at the derived equation. And of course you can check that that equation is true, and you know if you're right then. So let's just there's 4 examples here. So derive an equation for force, which relates force and mass. Okay, so probably you know that F equals ma equals mass times acceleration. So, but pretending we don't know this, okay, that's what I want to arrive at, but don't write that at the start, okay, of your assignment. So we want an equation, force, that links mass and some other quantity. So I am going to call the other quantity, hold on, let's call it X. Okay, capital X. Okay, so using dimensional analysis, dimensions of force is the dimension, oh sorry, what am I doing? Dimensions of force equals the dimensions of mass times by the dimensions of X, the unknown quantity. So rearranging this, the dimensions of the unknown quantity are the dimensions of force over mass. Okay, so we're told that force up here, and you can look up your table. So we've got ml over t squared. Sorry, hold on. We've got ml over t squared, and then that's divided by m. So that simplifies to, we've got, sorry, I keep, so the m's cancel, and we're just left with L over t squared. Okay, so we say since the is the dimension, okay, you should recognize this as acceleration. We can say force equals mass. So in our original equation, we had, if you look up here, we had timesed mass by, we had timesed it by the unknown quantity. So it's mass times by acceleration, which is what we knew to start with, but we have worked this out without knowing that. Okay, so this is what you need. So a lot of you had tried, or some of you had tried question 2, but you were starting with the equation that you know. You need to start as if you don't know it. Okay, so pressure and force. Hopefully you know pressure is force over area. So let's do pressure, and we want to relate it to force, and we want to times that by an unknown quantity, so we'll call it y this time. Okay, so using dimensional analysis, the dimensions of pressure, the dimensions of force, times by the dimensions of y. So rearranging this, we've got y equals pressure over force. Okay, so fill in what we know. So pressure is m over lt squared, and then that's ml over t squared. So bringing this up, we've got mt squared on the top, and we've got ml squared t squared on the bottom. So cancelling, the m's cancel, the t squared cancel, and we've got the dimensions of y to be 1 over l squared. So L squared is the dimension of area. Therefore, 1 over L squared is divided by area. Okay, so we've got pressure equals force times by 1 over area, which then you write pressure is force over area. So if whatever you get here is a quantity, but you know, upside the reciprocal of it, then it's divided by that quantity in the original equation. Which again, pressure equals force over area is right. So you just look up the equations for power if you don't know them. Some of them you might know, and just make sure you derive the correct one. Okay, so pressure, density. Let me see. That should say okay, that should say, sorry, that should say derive an equation for density. I'll change that in your notes. Apologies. So we've got density equals mass times by an unknown quantity, so we'll say z. So the dimensions of z are dimension of density divided by mass. Okay, so dimensions of z, so we're told density is m over L cubed and then over mass. Okay, so the m's cancel. So we've got dimensions of z is, okay, you should, L cubed, you should know that is volume. Therefore, density equals mass times by 1 over volume, which is the same as divided by volume. So density is mass over volume, which again is the correct expression, because we know these are equations that exist. But this is how you need to show it. Okay, and example 4, so resistance and voltage, and again you should know, oh sorry, so resistance equals voltage, and let's go back and call it times by an unknown quantity x. So the unknown quantity x is the dimensions of resistance over voltage. Okay, so using the table in the front of these notes. So ml squared over q squared t. Be careful with these because they're very similar. Ml squared over qt squared. Okay, so the ml squareds cancel, and we've got the dimensions of x. So this comes to the top, so it's qt squared over q squared t. Okay, and that cancels to t over q, which that is 1 over q over t, which is current. So q over t is current. Therefore, our original equation, resistance equals voltage times by 1 over current, which then you just write as voltage divided by current, which again you can look up, and that is a correct equation that's already out there. But we have derived it using dimensional analysis.